All right, yeah, since we ran out of time and since we started sort of late, I decided to make a video to explain the rest of the problem since there's a lot left on here. So I do want you to try them and pause it in between if you're confused or if you want to follow my directions as I go through it to make sure that you understand it entirely. Okay, so we have number 7 here. You said you're going to try this next. So hopefully this one's already done. So we have position and we have velocity. So for this first part right here, you're seeing that you're going from 0, you're starting at a position of 0, and he's moving at a constant velocity of, from 1 second, from 0 to 1, he's moved 2 meters, right? From 0 to 1, he's moved 2 meters. After 1 second, he's moved 2 meters. So in that case, this person is moving 2 meters per second for 1 second. Right, so we're going to go ahead and go up here on our little velocity graph, and we're going to draw from the very start. From the start, he's moving 2 meters per second. So I'll get my black pen right here for 1 second. And then things change. And you can tell things changed because of the slope of the line. The slope of the line is different, so that means something is different. In this case, we can get our little colorful line again here, and from here to here, he's moving slower, right? He hasn't even moved in 1 second. It looks like he's moved about a half a meter, right? And in 2 seconds, it looks like he's moved a full meter. So in this case, they're slowing down, right? So instead of moving 1 meter per second, it looks like they're moving 1 meter per 2 seconds. And what does that look like if I draw that right here? 1 meter per 2 seconds is a half a meter per second. A half a meter per second. So this might look a little different when we're drawing it over here. And that's constant. It looks like it's going to do that the entire time up until 5 seconds. So it's moving a half a meter per second. So in this case, I would draw a line down to about a half and go across. So that might be another concept that he didn't review, is how to get fractions here. He's moving 1 meter per 2 seconds, which looks like 1/2. And you can simplify that if you know how to do your fractions. Okay, so that's what that graph will look like. For these questions right here, for many graphs, both the slope of the line and the area between the line and the horizontal axis have physical meanings. What does the slope of a position time graph tell you about the motion of an object? So in this case, he's talking about these graphs, position time graphs. What does the slope of a position time graph tell you about the motion of an object? And we just talked about that in our last problem. So if you want to pause and think about it, go ahead and pause and think about it. So position versus time is telling you, depending on how sloped it is, 2 things. It's telling you how fast it's going. I guess, yeah, so for slope, you're just saying if it's going faster, it's going to have a sharper slope, or like a more vertical slope. If it's going slower, it's going to have a more horizontal slope, just like we see here, right? So you can say, and I don't know if I'm going to write this in because it's going to take me a long time to and it's going to look bad. So the slope of a position time graph tells you the speed. You probably want to write more than just this, though. You probably want to write a complete sentence. And again, depending on that slope, will tell you if it's moving faster or slower. So you can write that in there yourself. Letter B, looking at the velocity time graphs. Now we're looking at these other ones, the velocity time graphs. What does determine the units for a square area on the graph? Now this one might be very confusing. So now we're looking at these graphs on the right. And it's asking for, I'll use the highlighter here, what does this square mean? What does the unit for the square mean? And it's pretty simple to get this. So in our previous graph, a unit for a square, right, for this graph, is telling you the position in meters every second, right? It's telling you the meters per second. So for the position versus time graph, it's actually telling you the velocity. For the velocity versus time graph, and this is why I asked you this earlier about acceleration, it's telling you the meters per second, right? This one on the left is telling us the meters, I'll highlight it, the meters per second. And this one on the right, which is the question, is telling you the meters per second, right? So it's up to you how you want to write this. There is a correct way to do it. Meters per second. You can write it like that and have your teacher sort of explain it to you. But you can also write it like this. I'm not sure if he taught you about square units yet. So this is meters per second squared, right? And what this graph is actually telling you is acceleration. But you might want to wait for your teacher to explain to you acceleration. I'm not sure if he wants to be that advanced in your understanding it, because that's the unit for acceleration. So we have our unit for speed, meters per second or miles per hour. We have our unit for velocity, meters per second. And then we have our unit for acceleration, meters per second squared. Letter C, what does the area under the velocity time graph tell you about the motion of an object? So I'm assuming under the velocity time graph, I'm assuming what they might be talking about is this down here. So the area under the velocity time graph, it might be telling you the negative, that your object is moving backwards, has a backwards velocity. I'm not entirely sure what they're asking about under the velocity time graph. In this case, one correct answer might be the fact that if you get to the negative area, you're moving backwards, right? You're moving backwards, just like we saw with number 5 or whatever this is right here, number 6. Okay, so moving on to the next worksheet. This is I think this is a little bit more simple than the first couple pages you did. So let's read it. And again, go ahead and pause the video. Make sure you're pausing and trying it on your own and not just copying my answers. Written description: objects move with a constant positive velocity for 4 seconds. Then it stops for 2 seconds and returns to its initial position for 2 seconds, right? So you have to fill out everything for this. I might do the motion map last because we had a couple issues with that. So an object is moving with a constant positive velocity for 4 seconds. So we can say, it doesn't give you meters, so you're going to have to make that part up. So in this case, I can say that this is maybe 4 or 5. I can draw a couple lines here, and same with time. Again, I always like to put my lines in, and I would also write your numbers in here too, but because my pen is so thick, I'm not going to write the numbers in. So if it's moving at a positive velocity for 4 seconds, then that means this is meters, this is seconds. That means that it must be moving forward. It must be increasing its distance, right? It must be going more meters every second, right? For how many seconds? So objects moving at constant positive velocity for 4 seconds. So up to here, this 4 second mark. I'll make it a little more bold, and we can draw that it's moving at a constant velocity for 4 seconds. And then as soon as it gets to this 4 second mark, and again, make sure you're writing your numbers in here. I might do that too, just because it might get confusing if I don't do it. So we'll say this is 1, this is 2, this is 3, this is 4. And that's an S right there. It's not a 5. This is 5. All right, constant velocity. So that line is just constantly straight, as straight as I can make it. And then it stops for 2 seconds. That means for 5 and 6, it's moving no more meters, right? It's not going forward in space anymore, right? But it's still going forward in time. It stops for 2 seconds, and then it returns to its initial position in 2 seconds. So 7, 8, 7, 8. So it returns to its initial position, which I guess in this case would be 0. So we draw a line back down here at 0. So it's going to look something like this, and you can kind of see that your velocity does change here. So our velocity, we'll say that our velocity starts at 2 meters per second, right? Because we want to have room to go down or up if we need to. And in this case, we said it was constant, so it was moving constant for 4 seconds. 1, 2, 3, 4. So again, I draw my line straight across. And then we said it stopped for 2 seconds. So in this case, we have to have a velocity of 0. Have to have a velocity of 0. So I'm going to draw a line down. And then again, this is 1, 2 seconds. And then you can kind of bold it out a little bit. And then it returns to its initial position in 2 seconds. So depending on your slope of this line, again, it doesn't tell you how fast it was moving, or it doesn't give you the distance it was moving. So in this case, if it's returning to its original position, then that means, just like if you're driving a car, you drove a car forward, now you need to drive a car backwards. You need to hit the reverse to go back to your original position. So let's just say, and this part, I don't think it matters too much about the number, but we'll just say 2. It's moving 2 meters per second, negative 2 meters per second for 2 more seconds. Actually, no. I need to correct myself. You do have a little bit of a sense of the speed it's moving.